Okay, at first glance, we think this is no big deal. We can let u be x minus 1, integrate, plug in your 2 minus plug in your 0. But where does the graph of 1 over x minus 1 to the 4/3 have an asymptote? At 1, which is smack dab in the middle of those limits of integration. So from now on, you're going to have to be on the lookout for vertical asymptotes in things that you integrate. So what we're going to have to do is we're going to have to take the limit as c approaches 1, and I'm going to integrate from 0 to 1. I'm going to go back and put the positive or the negative on in just a second. Basically, I have to integrate from 0 to my asymptote and then my asymptote to 2. Yes. See, there's so much notation that even I get bogged down in it. All right, so then the other integral needs to be from c to 2. And 1 over x minus 1 to the 4/3. Okay, if your asymptote is at 1, and you're integrating from 0 to 1, then the graph is going to approach that asymptote at 1 from which side? The left side. So the first one needs to be as c approaches 1 from the left. And by default, the other one's going to have to be from the right. But if you think about integrating from the asymptote at 1 to 2, then if you go from 1 to 2 and the asymptote's at 1, that graph is approaching that asymptote from the right side. All right, how are we going to integrate 1 over x minus 1 to the 4/3? U substitution. I'm just going to go over here and kind of do it on the side. So if u is x minus 1, du is plain old dx, and I'm integrating u to the negative 4/3 du, which is going to be negative 3u to the negative 1/3. Or negative 3 over u to the 1/3. So limit as c approaches 1 from the left, negative 3 over x minus 1 to the 1/3 from 0 to c, plus the limit as c approaches 1 from the right, okay, that's a good question. Why didn't I change my limits of integration? I chose to plug the x's back in. The 0, the 1, and the c are all in terms of x's. So when I made the u substitution, as opposed to just bringing the u back up there, I went ahead and plugged my x's back in so I don't have to change my limits of integration. To me, that's just too much going on. All right, do y'all want to try finding these limits on your own? You can do it. Another x up here that should be a c on my limit. Okay, hold on. Let's go back to this plus 3 right there. Is that what you're talking about? Okay, so it should be minus a negative 3 over a negative 1. No, okay, disregard the C. We're not talking about the C. We're talking about plugging in the 0 right here. So we plug in the C minus plug in the 0. So minus the negative 3, and when I plug in a 0 right here, I get negative 1 to the 1/3. Negative 1 to the 1/3 is the cubed root of negative 1, which is negative 1. Right, so, but this minus sign right here makes it negative 3. Okay, so this should be a negative 3 right here, either plus a negative or a minus. But the limit as C approaches 1, you essentially have negative 3 over something that's tiny, tiny, tiny. And negative 3 divided by, say, 1/1,000,000th, it would still be a negative number. So you basically have negative 3 divided by a tiny negative number, so it's actually going to be positive infinity. Minus 3. Plus a negative 3 right here. And then that's going to be infinity also. So we basically have 2 times infinity minus 6, which is still infinity. So it diverges. We're not going to go all the way through number 4, because this just combines too much stuff at once. How many vertical asymptotes does this graph have? 2. Oh, no. Where are those 2 vertical asymptotes? Okay, 0 and negative 1. What's the good news, though? Yeah, negative 1 I don't need to worry about because it's not in my limits of integration. So my only vertical asymptote that I really need to deal with is at x equals 0. So to set this up, I would take the limit as C approaches 0 from which side? The right. Integral from C to infinity. But I can only deal with one thing at a time. So I can't use 0 because I've already got right here. So what do you want to break up between 0 and infinity? 1. Well, I can use any number between 0 and infinity, but I can't use 0 because I've already got that vertical asymptote at 0. So I just picked 1 because I have to think ahead to something that's going to be easy to plug in, and 1 would be easy to plug in. Well, we're going to, like the integral from 0 to infinity is the same thing as the integral from 0 to 1 plus the integral from 1 to infinity, or 0 to 203 plus 203 to infinity. But you have to think ahead that you're going to be plugging that number that you choose in to an equation. So you don't really want to pick a horrible number. Plus the limit as b approaches infinity from 1 to b. Okay. Now, any thoughts as to how you are going to integrate that? It's actually an arctan, where u is actually x to the 1/2, because u squared then would be x. A is going to be 1, and what is your du? One half x to the negative 1/2, which is what you have. You just need a 1/2 and therefore a 2 outside. Okay, there's way too much going on in this problem, okay, to go any further than that. But I just kind of wanted to point that out. You may see parts of this problem separately in different problems, but I'm not going to put all of that together.